show starts in 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, go.
Hello, can you guys hear me? Please explain the concept slowly. We are not genius like you. Okay, sure. Okay, hello, Mr. Nobody. Okay, hello, everyone. Can everyone hear me clearly? Okay, you guys can hear me, right? Okay, let's get started. So currently we have 14 people. Is it good? Okay, maybe someone will come later. Okay. Okay. So so for today meeting, maybe we have someone new, someone old, right? And I think that everyone know about the Leetcode platform. So let me introduce a bit about Leetcode platform. This is a Leetcode platform is very good for us to practice coding, to improve our coding skill, to prepare for big company like Google, Facebook, Amazon, or something like that. So you can see that there are a lot of companies, right? Google, Amazon, Facebook, Apple, something. A lot of problem. Currently, that Leetcode have totally near 2,000 problem. So for the beginner, I think Leetcode already prepare a tab. Let's say maybe they have create a tab, but let me check Leetcode, right? They have the post. That they have a study plan tab here. In the study plan tab here, so it's very good for newbie to start to learn algorithm and data structure in Leetcode. Actually, that algorithm they have algorithm 1, algorithm 2 here, and some problem. Just very small problem. Just 31 problem plus this one. Totally maybe more. Oh, maybe totally maybe 200 problem. So you guys can start from this study plan. I'm not sure that this is for everybody or just for premium account. I'm not sure. Yeah, this is for everybody. I think. Okay. And today I will continue with my series about Livecoding to solve Facebook Onsite interview problem set. Because my account is premium, so I have this feature for mock assessments. In this feature, that Leetcode will prepare a lot of problem sets for companies like Google, Facebook, Amazon, Microsoft, Adobe, Apple, Uber, something like that. And they have an online assessment, one interview assessment, and on-site interview assessment. Okay. Can you introduce a bit about yourself? Yes, okay. That's the way you Leetcode for interview. Yeah, I think every company also use some problem from Leetcode. So I think if you guys prepare well, you can solve common interview problem on the Leetcode. So maybe I think 200 is good for you to start to interview. Hello, good, not good. Hello, Shora. Not sure that I'm pronounce your name correctly. Okay. Okay, let's get started. Speak English, please, Wyndon, because we have some global audience here in this meeting, in this session. Actually, that for Facebook, I already saw finish 15 problem set. But now I will maybe I finished 1 year ago and I already forgot. So today I will live stream you guys to solve the problem, how I come with the idea, something like that, and answer your questions if you may have. Okay, let's get started. Zoom a bit. It's good, right? Okay. Okay, for the problem set here. Okay. It contains 3 questions. Okay. So as like usual, I will read the problem first and go through example so you guys can understand, and then I will from example I will come with algorithm and implement and tell the time complexity, space complexity, or I will come another approach if have. Okay. If you guys have any questions, don't hesitate to comment in the stream. Okay. Let's get started. Given two integer arrays of length of equal length, right? Given 2 integer arrays of equal length, tagging an array. In one step, you can select any non-empty subarray of array and reverse it. You are allowed to make any number of steps. So look like that. This I already saw this problem set. Actually, that this problem I already saw before in my previous live stream. So maybe I will change another one. Actually, that is a repeat. This problem set a repeat. Okay, so one guy have questions that do you have any advice of competitive programming? For my advice is that like I said you before, right? If you are newbie, you can start with the study plan as a Leetcode already prepared for you guys. It have a algorithm 1, algorithm 2, data structure, and dynamic programming topic. If you guys want, if actually that you guys need to know about basics, some basic algorithm. So I prepare some. Let's check out all the topics. We all the topics. So they have a lot of topic, right? So a lot of topic. So yeah, I suggest you guys that start from a study plan. Like Leetcode already prepared for you guys. And if you want to check to learn a new topic that you didn't know, I highly recommend you guys to check out about CB algorithm. This website is very good for you to learn a new topic. For example, that I want to learn about union fight. So this topic is have the image to visualize, naive implement, and some optimize like using path compression, union by side rank, time complexity, and a lot. So you guys can read from this website, very useful. Okay. How would you suggest that data structure and algorithm? I already answered it already, right? What do you think about learn section in the Leetcode? The learn section, where is the learn section? The learn section, the learn section. Actually, that I don't know about the learn section. And I highly recommend you guys join the Leetcode contest as well. This is very fun, very fun. They when joining the contest, they host the contest every week and every bi-weekly. So every week they have the contest like this. So you guys can join and solve problem while you guys can earn the coins. If you guys have coins, you guys can redeem for clothes and laptops, leave something like this. It's very fun. Okay, start learn. Explore learn. Explore learn. Explore learn. This one. Maybe I have four, but I haven't tried, so I don't know. Actually, that I think practice make perfect. I already solved more than 1,000 problems on the Leetcode, so I currently I'm a bit confident about my coding skill. And I already you guys can see that I already joined more than 100 contests in the Leetcode. On the day before, you guys can see that my rank is very low, right? You guys can see that the contest rating is very low, like this. Yeah, and then I improve, and now I can in the top of 1,200 compared to 90,000 participants. Okay, so let's get started. Actually, that this problem I already saw before in my previous live stream. Look like that. This duplicate K again. So maybe I can change for Google on-site interview. Google on-site interview is a bit harder. Google on-site interview is a little bit hard compared to Leetcode, compared to Facebook. Okay, let's get started. Actually, that's the problem I haven't solved before. Okay, so the Google on-site interview, we have 3 sections today. Okay, you are given string S consists of lowercase English letters. A duplicate removal consists of two adjacent and equal letters and remove them. We repeatedly make duplicate removals on S until we no longer can return the final string. After all such duplicate removal have been made, it can be proven that the answer is unique. Okay, for example, we have this string, right? And so first of all, we mix A and we mix B and we mix B again. So we remove B and we come with A here. We remove A as well, and we come C and A. So the result is CA. Okay. Same with this example. A, Z, X, and mix X here, right? So remove X, Get Z here, right? Remove Z, and if you let AY, and the result is AY. So, okay, you guys can see the length is less or equal to 10 exponent by 5. So we can do up to n log n, up to n log n. Okay, so from the example that we can see that it look like a stack, right? We A here and B here, and we mix B, we just remove B. We mix A, and we remove A, and remain C and A. So if we have the stack, we have a stack. So if the stack is empty or the current character is different from the top of stack, we just push to our stack. If the current character, right, is equal to the top of stack, we just pop the top of stack. Yeah, and finally we output the remaining result. Okay, question 1 can be using Q data structure. VJ use stack. Yeah, correct. Okay, so problem 1 is quite easy, right? Okay, let's get solve it. I have a stack here, and I look for my string, and I get each character here, and then if my stack is not empty and top of stack is equal to current character, I will pop my stack L. I will push into my stack again, right? Okay, and then I just get or print all the result by choice all character. Okay. CA, right? AY, right? Okay, quite easy for the problem 1, right? So time complexity for this problem will be ON because I do linear time like this, and the space complexity will be the stack view up to ON. Okay, we already done for problem 1, quite easy. Okay, let's move to the problem 2. Okay, you are given a string S representing a list of words. Each letter in the word has one or more options. Okay, we are given a string S represent a list of words. Each letter in the word has one or more options. If there is one option, the letter E represents as is. If there is more than one option, then the curly braces delimit the option. For example, that this one represent option A, B, C. For example, that if we have the string S like this, the first character is only A, but the second character can be B, C. So the original list will be A, B, and A, C. Return all the words that can be formed in this manner, sorted in lexicographical order. Okay. Okay, so let's go through example. We have example 1 like this. So actually that we have one character, we have 2 options, and this one have 1 option. This one have 2 options. So we combine all them together. For example, we A and C and D, A, C, D, and A, C, with the F as well. Yeah, and A, C, E, F, A, C, E, F. The same with we have B, C, D, F, and D, C, E, F. Okay, so we have 4 options. We need to output in lexicographical order. Okay. Some guys suggest the solution that use sorting, recursion. Some guys use backtracking. Yeah, actually that this kind of backtracking problem. Yeah, you guys can see that the constraint is very small. Okay, we have the length of string is less or equal to 50. String contains a curly bracket, right? A comma and English lowercase letter English. Okay, S is guaranteed to be valid input. There is no netted curly brackets or the character inside a pair of consecutive opening are different. Okay, so okay, let's check this example again. Okay, so we just get the open bracket, right? So we can get all the string here, and we can mark with close here. So this will be so the idea is that we use the stack to match open with close here, and then we can solve the problem in this string with this string with A, B here. Okay, and this solve function will return a list of string, and then we concatenate with this string, right? And then we concatenate with solve of string DE, and we concatenate with F. Yeah, that's the idea. So we need to define a function like dfs or backtrack how to say dfs or backtracking is okay. Define backtracking. Okay, and we have the string here. So we need to return a list of string. But first of all, we need to there is no nested curly brackets. So first of all, we can have some group. Okay. How do we backtracking? For example, if we saw this string, right? So we just split. We have some characters. Character here is only lowercase letter, right? Okay, so we have some character here, so we can split by like this. So we have some character here, and okay, we have A, B here. How can we join with C? So this S is not just show for this. This S need to care about the brackets as well. So how about we have the stack here, and we look our character in our string here, and let's keep my code. I look character here, right? So if character here is the open bracket, I need to map with the close. Need to map with close. So so my stack here will store the index of the string. So if I have the like this, right? I will add my stack to this index. If I need the close bracket, so I can have the string AB. So I have the string AB. I will call to solve the problem with the string AB by actually that I can get the substring as well. The substring I need to get the start index. Okay, that will be this stack dot pop. I will have this start index here. I need to show the problem with the start index +1 because I skip this open colon brackets. So I will start with this, and I have this string, and currently this is the index I, right? So I will up to I here. Actually I here is exclusive, so it's the correct. Okay, then I have the result of this one. The result of this one. Okay. What happens if the string doesn't contain the bracket? It doesn't contain the bracket. For example, that hole like this, and it doesn't contain the bracket. Maybe maybe I keep the string so far. Right? Maybe I keep the temporary string, something like that, so that I can show the problem without bracket after my for loop here. So after I have this I need to have my answer here. For example, that if I solve the subproblem like AB this, right? So I need to look for each problem, and I will continue to solve with the left one. I will look for it. I look for the result from the previous one, right? Result from the previous one. Need to look result from the previous one, and for example, this return A, and I need to solve with this problem. So I need to combine them together. Or maybe just we just solve the first group only. Maybe we just solve for the first group only, and then we have so maybe we solve this the suffix first. After we solve the suffix, we have some element, and we product with the current element now. Okay, someone have some command. it's possible to use Java encoding. I think Java and Python are the same, but Python is more quickly to express my idea. Okay. Okay, I will continue with this problem. Okay, how about that? I just show this only, this sub only, and then I will recursive to show the left one, so that I can product the current here with the next one. Can write. Okay, so I just show. Okay, when I mix the end right like this right, I just call to show the okay, I will have the array will be I will have the function like split get letter something like that. No need that. So I will split directly. Okay, I have the substring like this right. Let's substring. Okay, like this, and then I will split some. Okay, I will define a function to avoid repeat myself. Okay, get element from my string here. Actually, that from the string S, I split by the comma. Okay, and I have element here. Maybe I have the start index. Start index will start with 0 and have the end index will start with -1 with the end of string. Okay, and if I mix the open and close like this, I will update my start to this letter right, this index right +1. Okay, and the stop right, the stop will be end index of the current index here, -1. Okay, I have the start and end, and I have the need to store the next index as well. Next index initialize with 0 or -1. Okay, next index will be initialize with length s. If I make the first bracket right, I have the start index, the end index here, and the next index will be letter C. So I will have the next index will be currently index I here right, +1. I +1. Okay. Okay, and then I break my loop. Break my loop. Okay. Now I will have some element of the current by I get element of the current string. The current string that doesn't contain bracket. So the string from start index and end index +1, because this is exclusive. Okay, and I have the array. Okay, and then I call backtracking to show the next problem. So this is array 1, this is array 2. Call backtracking to show the next problem. Okay, so my next problem will start from next index. Okay, So I already saw the current problem. I saw AB. I have AB, and I saw the next problem will return a list of string. So I just product themselves together, concatenate themselves together. I have answer here, and I just for one from array 1, right? For I2 for A2 from array 2 here, I append them together. I concatenate them together. What happens if this return empty array? So at least we need at least this one will return the one element with empty string in that case. Okay, so we just this one and concatenate with A2 and return our answer here. Okay, so what is the base case of our backtracking? If the length is empty, right? Length is 0, right? So we need to return, like I said before, that we need to return array with empty string. So this one can look and concatenate with empty string to return our answer. Okay, so let's test our backtracking function. Let's test with this example. Backtracking from string S, right? Okay, let's test with the first example. Not enough value to impact in string here. I need to enumerate. This is the index, is the character at S. Okay, so I have A, D, E, F here. So I make C. I make C, right? I have A, D here, F here, but I mix C. So let's check why I mix C. Okay, so my algorithm will show this one and continue with this one, and actually that this one need to return C. 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 So we need to check. So actually that if we only do this one when the next element is open bracket. When we do this one, otherwise we will skip the letter C. Okay, so this one we will so we just do the if else. If the S0 is open, so we don't need stack. We don't need stack anymore. We just find the close. We just find the close. Just find the close. Okay. We need to look from I into 1 into length of S. So if the string S index I is closed, we need to, when our first capture is the open, we need to find the close, find the close matching. Okay, after we find the close matching, we don't swap anymore. So our start index will be 1. and this is the end index, and this is the next index we break. Otherwise, if the current character is a letter, we need to file open. We need to file open. We need to file open. File open. File open. So for I in 1 to length s is st equal to open. Open. If it's open here, we need to know that next our index will be this current open, right? We store this current open here, and our start will be 0, right? And our end will be this one minus 1. This one minus 1. I minus 1. And we break our algorithm. Otherwise, we use the default value. If it doesn't file the open, so it means that all our letter or all our character in our string is characters. So it will use the default value like this. Okay. Sound correct? So let's run again. So A, C, D, F, right? A, C, E, F, B, C, D, F, B, C, E, F, correct? Okay, let's try with this one. Okay, correct. Let's run. Oh, maybe we need to sort as well. I sorry, I forgot to sort my answer. So just sorting my answer like this. And test with this example. Okay, correct. A stop of code. That will be also very similar. Keep popping until you get the same character in the string. Make the list of lists by pre-process and recursive. Choose one from each position. So this one I do the intuitive practicing. Actually, that the overall idea is that if I make the open, right, I will find the close matching, and where I will get element in this first group, and then I show the whole string, and then I concatenate them together. That's the basic idea. Okay, let's continue with the question 3. Do you guys have any questions? What's the time and space complexity? Okay. Actually, okay. Okay, the time and space complexity, right? Actually, that it look like that for it look like that how to check the complexity, right? complexity is actual, for example, like this, A, B, C, D, and E, F. So choose for the first group, it will have two options. Choose for the second group, we will have two options. To the third group, we have two options. In this case, like this, is there any in the worst case? Is there any in the worst case? In the worst case, maybe contain up to 26, right? 26. If it contain 26 like this, if 26 like this, each character will include the comma. So in this case, we get 26, right? But how about we divide by 2, right? For example, that A to something in the middle, A, B, C, D, E, F, G, H, I, K, something, M or something, and we have another group like this, N and to Z. So we have this one is the half of 26 will be 13 multiplied by 13 will very small, will not larger because the length is limited by 50 and we have some comma. So the different so all the letter will less than 26 will less than 25 or something like this. So the time complexity will be it's hard to say. It's hard to say. How to approach rap problem. Rap problem. A rap problem. A rap problem. So this is we have A B. How can we wrap this? We have A B, right? A B, and we have the C here, and we have D, E, and finally we need to find all the paths from the starter. So you mean that for the grab approach, right? Grab approach. We have something like A and B, and with the C here, right? And with D here, and E here, and this is the F. So we need to find all the paths, right? To find all the paths. We can leave as this is the first level, and this is the second level. Second level. So the second level will product with the first level, and we have AC and BC here, and we BS on the third level like DE here, and we just concatenate them together. The E here, and we have the F here. We missed something. So level by level, first of all we have AC, right? AC, we have AC and BC, and this one we for we have this one, and this one we have D and D here, and E here we have AC, E, BC, E here, and finally we concatenate with F together. Can BFS also can. We can use the BFS to solve this problem by traverse level by level. So let's go to the next question. Okay, so design an algorithm that accepts a stream of characters and check if a suffix of this character is a string of a given array of string words. For example, words here, A, B, C here, X, Y, Z, and the stream. Okay, I have the word right, and the stream adds 4 characters, one by one. A, X, Y, and Z. And your algorithm should detect that suffix X, Y, Z of the character. This one match with this one from the word. Implement stream checker class. Initialize with the array of words, and a boolean query. Accept a new character from the stream and return true if any non-empty suffix from the stream. Non-empty suffix from the stream form a word in words here. Okay, actually that's the problem set that we need to design the system, and this is the stream checker system, and it accepts initialize with an array of words, and add into our system. So when it will query, it's something like it's typing character. For example, it's type A here, and type, and it check if A here, if suffix of the current string, because it only have one character, right? And it suffix also A, and it doesn't exist in this words here, so it's return false. We will type B here, B, A, B or B both do not exist in this, so it's return false. C here, BC or ABC or C do not exist in the stream check, so it's still return false. And when it go with D, right? Type with D here. We have CD here exists in the words, so we need to return true. Here because CD is in the word list, and continue with the E here. E or the E do not exist in this return false, and continue with F because F here exists in the words here, so we return true. Continue with J, G, return false because G doesn't exist. Continue with H still false because we doesn't have any words contain the suffix of this word. Okay, continue with I, J, K, L. For the L we have KL here, exist in the word list here, we return true. Okay. So for this problem, we can see that how about we use a three node structure, trie structure, right? If we build a trie structure, a list of words here, we need to traverse every time we need to traverse from the last to the first. So we will compare to our words. So each time query will take O O of O of O of length of longitude length of word longitude will be this one. Length of longitude will be length of longitude, right? Will be less than 2000 here, and we have the number of query, right? Number of query will be 4 multiplied by this one. So if query we multiply by this one, this may call TLE approach one. If we use 3A node and with the number of query like this, and each time we need to multiply by this, it will take this one multiplied by this one. Will be 4 multiplied by this one, multiplied by this one will be 80, right? 80 multiplied by this one, may call TLE. But first of all, to mark this one, first of all they need to build a string. They need to build a string 2000 first to mark this one. So it have total 4 multiplied by this one time, right? But first of all, it need to have build for the first 2000 first. And 2000 here will multiply by something also the same. So this one may call TOE. So let's check if we can have another approach. Do you guys understand the approach one? Do you guys want me to explain again? Okay, in the pro one, in this one, it may have some rules, so I think can pass in C++. You want me to explain again? Okay, actually that my algorithm here is that for every word like this, right? For every initial words like this, I will build a 3A structure. For example, that I will present for you guys to see clearly. For example, that I have this word. Have this word, right? Have this word. This word like this. I will build a 3A structure. 3A try. The try. I will build because I want to map the words, right? The whole word, right? So I build a with the root here, and the root here with the letter A, and A will come with B will come with C here, and this one the same from root I come with X here, and come with Y here, and come with Z here. So when I type a word, right? For example, that I type A, B, C, D, right? A, B, C, D already. So I just traverse from each character from the last to the first, the end, the right to the left, right? So I mark D here. I check. Actually, that I use this example. So for example, that I type A, B, N, A B D A B C, right? For example, I type this string. So I will check. I will traverse from the right to the left for the C here. For the, I will copy into this. Like this. I will traverse from the right to the left. So for the C here. No, actually that I need to build in reverse order so that I can traverse from the right to the left. So this word oblique I need to build something like from the reverse order with the C first, and with the B, and with the A, and this one the same with the Z, and with the Y, and with the X here. So this one I just traverse and mix C here, right? And I found here. I will continue B here. I found B here. A here. I found A here. And this node I mark is word equal to true. So it's end of word, so I return true. Yeah. This is my my algorithm using GA. Hello, Dung Nhiên nha. You guys can understand, right? Let's implement this. I think this one with some rule can work in C++. Okay, let's implement that approach. So let's implement. I have the 3A node, right? This, right? Let's use C++. Okay. Okay. First of all, I have my node view. My node should be used by tunnel to C++. Okay, C++. Okay, with the private, I have a clear node with the children. It will have totally this one children with the initialize with null. Okay. Then I have a function like remove this one. Have function like void, right? Edwards, something like this. And with the string words, and I need to traverse in reverse order equal to words dot size 1. Okay, and I have the how to say the current, right? Will equal to this first. Then I add if I have a catcher, the will be first S index, right? I plus by this one, so I can have this the value in from the 0 into 25. Okay, so if cur dot children C equal to null pointer, we need to create a new one. Okay, then we set cur equal to current children. Okay, it works in reverse order, thing like this. Okay, and finally we need to mark our cur here have a boolean value Boolean value like keyword equal to default with false, right? So when we end up our node, we set it to. Okay. After we add the words in reverse order. So in this case, we will check Boolean both. We will find the search for the current string, for the string button or something like this. So when we query, right? When we query, we need to keep a current string. Let's name it Thai or something like this. Thai already Thai. We already Thai. So first of all, we need to build. Need to create a node root. Create root. Okay, and we just call create root dot add words in reverse order of words. Okay. Each of time we just Thai plus with the letter here, and we search. Return search create root here. Our create search for the Thai if there is any match or not. So how to find in our pattern here? First to have a curve as well. Then we iterate from the reverse order as well. Pattern dot size -1 0 if we need to get the index by get the pattern of index I minus by catcher to get the value from 0 to 25. Okay, if it exists, if it doesn't exist, right? So it means that our letter doesn't exist in a words array, so we just return false. Otherwise, it will exist, right? Otherwise, it will exist. We will continue. We will check if we will get the current children. If the current children, right, is the word, we found a word in our try structure and 2. Otherwise, we will continue. Finally, we don't find anything, so we return false. Okay, that's all. Let's run to fix some syntax error. This is a pointer, so I remove this. Here, private member, public here. Okay, will be null false 4, right? Null 4 here. Sound correct? Null 4 false. Null 4 false 2. 4 2 4 false. Correct? Let's check our code again. We have a children here in words here add in reverse order. So traverse in reverse order, get the index. If null, we create a new one and jump current to the children. And finally, we set that word and E2. When we search from the reverse order as well. We get the index. We check if this doesn't exist in the try A, we return false. Otherwise, we jump. If we found any n words, we return true. Otherwise, we return false. Correct? Okay. Okay nè. Got it. Yeah. Okay.